Today we will see how to deal with the composition functions. That is, how to find the derivative of the composition functions. First, we will talk about what type of functions are composition functions. So if there are two functions, f of x and g of x, and both functions are differentiable at x, so composition functions of the type f of g, which means that function f is dependent on g and then g is dependent upon x. F of g of x, this is known as a composition function. So we will see how to find the derivative of the composition functions and what is the easiest method to find the derivative of such functions. By using all the previous theorems that we see earlier, so finding the rate of change of y with respect to x, so here is also x is the independent variable and y is the dependent variable. So rate of change of y with respect to x of this composition function would be the derivative of this function, then the rate of change of this function on which f depends upon g, so the rate of change of g of x with respect to x, and then again rate of change of this x on which x is dependent. Then we get f dash of g of x and g dash of x, and we get 1. This is the base method of finding the rate of change of all the functions, whether it is a composition function or whether it is a polynomial or quotient or any other function. But we will use a rule here that is known as chain rule. We will use chain rule and we will see what is the benefit of using the chain rule in order to find the derivative of the complex functions, in order to avoid the mess during finding the derivative of such functions. Now, talking about the chain rule, so chain rule says that in the case of the composition functions, if we let g of x to some other variable, let's say t, if we suppose g of x to some other variable t, then the function f of g, that the composition function, will becomes f of t. Now here f is dependent upon t, it depends upon t here, and now as this is equal to y, eventually here y is a function of t now and t is a function of x. Here we have two dependent variables, t and y, where y depends upon t and t depends upon x, while x is an independent variable. In order to find the rate of change of y with respect to x, what we have to do? We just have to find the rate of change of this dependent variable with respect to this independent variable, and we have to find the derivative of y with respect to t. We have to find the derivative of t with respect to x, which means that we have two equations, or we can say that we have two functions, two different functions. Now finding the derivative, rate of change of t with respect to x is equal to g dash of x, and then finding the derivative of y with respect to t is equal to f dash of t. But we have to find the derivative of y with respect to x. So by using the chain rule, what is the main use of the chain rule is this, that we can write dy by dx is equal to dy by dt into dt by dx. This is what the chain rule says, that after finding the rate of change of both the functions with respect to their dependent functions, in the end we have to use this thing. Now by using this chain rule, by using this rule, we can find the rate of change of y with respect to x. So let's see. Now we have to put in the values in this equation. Dy by dt is equal to f dash of t. So f dash of t into dt by dx is g dash of x. And I just want to write all the function in the form of x and y, so putting back the value of t, that is g of x, f dash of g of x dot g dash of x is what the rate of change of y with respect to x is all about. So why we use chain rule? As you can see, it swipes the mess and brings out a clear picture. It is really important in very complex functions because there is a lot of mess while doing the derivative, while finding the derivative of the complex function. So chain rule brings a clear picture after processing in the background of how to find the derivative and what is the base process is going on. So we will see it by using some examples. But the chain rule, it's not only about finding the derivative or solving the composition functions, but also some other functions just to make the work more easier, such as if I have the function y and f of x is a very complex function and to the power some power n, or the power is very complex. So in this case we can also use chain rule by letting the function to some other variable t, or whatever it may be, u, v, x, or x, but w, etc. Or if the power is very complex, so we can let n to some other variable. As I have already told, that the use of it can make the complex functions more simple, and in order to find the derivative, and it can make it more easy and clear. So in the next video we will see how to use it, and we will solve some of the examples by using chain rule. Stay tuned. Goodbye.